Hey everyone. Okay, so I just wanted to show you a couple more examples of using the nth root theorem to solve for the complex roots of an equation. So on the left here, it's already worked out. I just took one that we've kind of seen before. You probably saw it last year in Algebra 2. Okay, x to the fourth minus 16 equals 0. We can solve it by factoring. Use the difference of squares a couple of times. We have x squared plus 4. Okay, which we can't, we can't factor that, but we can use the imaginary numbers. So we get plus or minus 2i there. We get x is positive 2, x is negative 2. Okay, so for this equation here, we know the four answers we're going to get are 2, negative 2, 2i, and negative 2i. So let's do the same problem, but using the complex polars way of doing it. Okay, so let's take a look here. I'm going to get it equal to 16, so x to the fourth equals 16. And we're going to write it in an a plus bi form, so 16 plus 0i. All right. Now, if I want to convert that to polar complex form so that I can use the nth root theorem, okay, and I'm thinking of this is my a plus bi, so if I wanted to make a quick sketch of this on the complex plane, I would go along the horizontal, 16 to the right for my A, okay, and 0 up or down for B, okay, so I'd get that. So writing this in complex polar form would be my radius is 16, okay, CIS, okay, my angle is 0. My angle is 0 there, okay. Now let's take the fourth root, so we'll raise to the 1/4 power, x to the fourth to the 1/4 equals, so now using my nth root theorem, I'm going to do 16 to the 1/4, and then CIS 0 over 4. Okay, well, these are going to give me my solutions here, so x sub 0, my first solution. Okay, what we're doing is we're going to be starting at an angle of 0, so the 0 divided by 4 gives me my start angle, right? So we'll start at 0, and let's do this in degrees because it's a little easier to kind of count and add in with degrees. And our increase, the amount that we're going to increase to find each angle, okay, so we're going around the entire circle. I know I'm going to have 4 solutions, so 360 over 4, that's going to give me 90 degrees is my increase. Okay, so we say 360 over 4, which is 90 degrees. So every time I do this, I'm going to increase by 90 degrees. So 16 to the 1/4 is 2, right? CIS 0 degrees to start. And then for each of these, my radius is still 2, but I'm going to go up and increase by 90 degrees each time. So then 90, 180, and my final one is 2 cosine I sine 270 degrees. All right. Now, if we go back and we're going to take these and convert them, right, back into rectangular form. Okay, I like pictures. Okay, it helps to look at a picture here. So if we're going to take my x0. I know it's a radius of 2 and an angle of 0. That's right there. Oops. Okay, so my radius is 2, my angle is 0. I can just convert this, just looking at the picture, into a plus bi, because I know a would be 2, and my b is 0. So I'm going to rewrite x0 as 2 plus 0i, which is just 2. Alright, so I got one of my answers from the left. Now let's do x1. Alright, my picture for x1, that's 2 cis 90. That's up there. Okay, radius is still 2. Right. Again, I can just write this in a plus bi form because I can tell, based on this picture, that a is 0 and b is 2. So now, that's going to be 0. A is 0 plus 2i. Well, that's just 2i. Well, there's my second answer that I already knew. x2 Same thing, draw my picture, running out of room. This one's at 180, so radius of 2, angle of 180. Okay, that's there along the x-axis at -2. So now I know my a is -2 and my b is 0 because it's not up or down at all. So it would be -2 plus 0i. Well, that's just -2. There's my third answer. And x sub 3 will be over here. That's 270 is my angle. Again, it's a radius of 2. So this time I know a is 0 plus -2i, or -2i. There's my fourth answer. Okay, so we use this method, we get the same 4 answers. Okay, now it seems maybe that's a lot extra work for a problem like this, okay, when we could have just factored. Right? But it can be really helpful for a more complicated problem. So here's an example of maybe a more complicated one. So this is find the fourth roots of -81i. This is actually one of your homework problems, number 79. Okay, so what this is saying is we want to find the answers to the equation x to the fourth equals -81i. So just like we did on the last one, all right, I'll take well, first I need to write this in complex polar form. So really this is 0 minus 81i, and make my little picture. That's going to be down here. Okay, so I could tell you right now that this is x to the fourth equals, my radius is 81, no negative radius, all right, my angle, so cosine I sine, all right, my angle is 270. Okay. All right, so then I'm going to take the fourth root, so x to the fourth to the 1/4 equals 81 to the 1/4. Cosine I sine 270 over 4. All right, that gives me my starting angle of 67.5 degrees and a increase of 360, so all the way around the circle. 4 answers, so an increase of 90 degrees. So I'm going to write out our 4 answers here. The first one would be x sub 0, so the fourth root of 81, square root is 3. Cosine I sine 67.5. And then I'll get the rest down here. So when we go through and add 90 each time, we get these answers: 3 cis 157.5, 3 cis 247.5, and 3 cis 337.5. Okay, so then let's just expand these out. So we would get 3 times cosine 67.5 plus sine 67.5, or plus I sine 67.5, and we could do that for the rest of these. So there's our expanded answers. If these were nicer angles, we could evaluate this better. If this was our unit circle angles, we could also find the decimal approximations for these. We're not going to do that right now. The other thing, you can do this using radians. So if we take 3 pi over 2 is 270 degrees and divide that by 4, we get 3 pi over 8. So really we would have a starting angle of 3 pi over 8, and we would be increasing at pi over 2, which is like 4 pi over 8. Okay, so we would have 3 pi over 8, 7 pi over 8, 11 pi over 8, 15 pi over 8. And similarly, we're not going to evaluate those, we would just leave those in here. So hopefully this helps a little bit, helps you get started. The other ones, 77, 81, 83, are all similar to this one. Just got to start it off as the x to whatever power equals that number that we're trying to find the roots of. And then 87 is another equation, so you can do that similarly to the first example here. Thanks.